So for now, we don't have any questions yet. So what do you think is the kind of most important missing thing right now for people to understand, like even with Faros, for people to understand what is happening? Where's an opportunity? Where's kind of a need to improve?
So Faros helps the process, but it's still a manual process. So you need to actually see the reports. You need to have an understanding of how things work, and you need to go through the report to find what's happening. So there needs to be some more work to be able to automate this analysis, like filter out some optimizations that are only happening as OpenMP artifacts and make those reports easier to read. So this is one thing that we want to also work and improve. And now on the sense of what kind of optimizations are actually missing because of OpenMP compilation and creating problems. I think that we need to have the compiler become more parallelism aware, so understand the OpenMP semantics better, and also understand how these propagate during this outlining process to be able to have those optimizations applied.
Okay, yeah, makes sense. Ravi asked if Faros is open sourced.
Yes, so there is some bureaucracy that needs to be done to open source it, but we are in the process. It should be out in 1 week, in about 1 week's time, and I would be happy to share the link with the workshop. Then I can also add it to the YouTube presentation, I guess, when YouTube are gonna be out.
Very good, nice. Bernd, do you want to ask your question?
Yes, can you hear me?
Mm-hmm.
The question is, isn't it the quality of the OpenMP outlining procedure in the parser that's at the end confuses the optimizer? I've been working with OpenMP for 20 years now, and I've seen it with all different kinds of compilers. That one of my favorite examples is this pi example that we all use when we teach OpenMP. And if you do a 1/n inside the loop, then some compilers cannot see that this can replace it by multiplication, and sometimes you get better results. So shouldn't we work on the quality of the outlining parser, that it does the things correctly? I think you mentioned that with turning it into a pointer confuses the optimizer in the other end.
Yes. So I think there are two aspects here, two things. One is how is the programmer is actually specifying the program, and this can create problems on how the outlining is going to work. So in the example of the SRAD, there was no real point on why this variable should be a shared variable. So this goes back on how developers can, how to teach developers to effectively express the parallelism that makes it easier for the compilers. Now, when we go inside the compiler, it should be the outlining being done very naively or without having those optimizations or this parallelism aware understanding is actually hurting performance again. So yes, improving the outlining and improving the semantic information that goes into outlining and into the compiler optimization is definitely a very valid target and a very valid thing to do. And again, going to the SRAD example, by improving the interprocedural optimization to be able to peep through this outline function, actually solve the problem. So it's also part of making the compiler smarter after the outlining part is done.
So in principle, the OpenMP people and the optimizer people, they should work closer together.
Yes. So we're trying to do that. So I'm also involved in the OpenMP optimization inside LLVM. So yeah, I mean, we need to work closer together, and we need to work. OpenMP people need to work in the compiler as well.
Maybe to give some more context, LLVM or almost any compiler so far I know of, just gained, I never had OpenMP or parallelism optimizations per se. There was nothing OpenMP specific or parallelism specific in LLVM ever. And it just gained or starts to gain the ability to optimize OpenMP codes. And that is really new, and that is, it's about time, obviously, but it's just coming. And at the same time, it took until the OpenMP 5.1 standard to have a default first private clause for the parallel directive. Because for some reason, initially in the early days, they made the default sharing behavior of a parallel shared. And to this day, I think that was the worst decision they could have made or the worst decision they made in the standard. Because 95% of, maybe more, of all variables that are implicitly shared in OpenMP should be first private. And either we teach the people, which is kind of too late already, because literally every book, everyone thinks it has to share stuff, or we make the compiler smarter, and we try to kind of give the people now an opportunity with the first private default, and at the same time do the compiler make the compiler smarter to get to a more favorable result. Colleen had a question. Oh no, Ravi is first. Sorry about that. Ravi, you want to ask?
Yeah, I mean, so how do you plan to support target constructs?
Yeah, that's a good question. So in terms of getting the compilation report out, we should be able to reuse whatever LLVM outputs as remarks. In terms of the execution, we need to support better. I mean, if the program outputs specific execution time information, then apparently we can run the program, let the thing offload to the accelerator and measure the performance then. If we want to make it more targeted, like we want to only measure what happens in OpenMP target constructs, then we need to extend a little bit Pharos to give some kind of instrumentation inside the program for Pharos to use.
But then your target and your sequential program is running on the host, or you're still, what is the sequential program in that case?
Sorry, I didn't understand the question.
So your sequential program is ignoring the pragma construct, right?
No, basically what's going to happen is that we're going to compile the program including the target directive, and then we're going to execute this program as it was compiled. So if it has a target directive, it's going to offload to the GPU, and we're going to measure the execution time of the program like that.
And compare against what?
That's against the sequential execution without the target directive.
So you're running on two different architecture, right?
Right. Yes. Yeah. Yeah. I see the point now. Yeah. Yeah. That's a good question. Yeah. I need to actually think more about that. How would that compare?
So one suggestion would be you would run the target as on the CPU itself, which OpenMP has capability.
Right. Okay.
So you're offloading, but you're offloading onto the CPU.
Right. Right. It would be interesting though to see what's going to happen in the GPU side if you would execute.
No, you can execute, but you cannot have a base to compare against.
Right.
That's the problem.
Yeah.
Assuming you want to compare execution times.
Yes.
Okay, Colleen.
Yeah, maybe somewhat related was, are you only using time as a metric for like better or worse, or have you thought about like counting number of memory operations and comparing just additionally?
Yes, we would like to do that. We would like to include more profiling information besides execution time. And this is one extension that it shouldn't be too hard. It's straightforward to do by including some kind of profiling framework within Pharos.
Okay, cool, thanks.